Hello, everyone. Thank you for joining the CSI Secrets Store call. Today is April Fool's, April 1st, 2021. And for those who are new and or joining, just remember this call falls under the CNCF Code of Conduct. And let's go ahead and get into our agenda for today. Again, if you are joining, go ahead and just add your name as an attendee and your organization you're affiliated with. And with that, we will go ahead and jump right into our agenda. It looks like we're going to kick it off with Anish, the release plan for today.
Yeah, so the release is planned for today, the 0.0.21. So there are 3 outstanding PRs. I think 2 of them have gotten merged. They were reviewed this morning. So there's one last PR to bump the version to 0.0.21. So once we merge that, we'll go ahead with the process. So hopefully we'll have a release card in the next few hours with all the optimizations that have gone in. So this is actually, I think, one of the biggest releases because we have had a bunch of PRs go in terms of features and also in terms of optimization. And also we've added a load test doc. So we've added the load testing environment and then the kind of test that we ran and then the memory limits that we saw. And then I've also added a small snippet in the doc for users to understand how our memory consumption increases. So what are the variables that it depends on, so that it's easier for them to scale if they're increasing certain components in the cluster.
All right. Any comments from anyone on that? Okay, sounds straightforward. Thanks, Anish. All right, next up we have Tommy. We're going to talk about rotation and deleted files.
Yeah, so this kind of goes into the next topic, but as I was looking at the how the driver might do the writing of files instead of the plugins, I'm not quite like there's some changes to the proto that are going into the next release to allow us to start exploring moving writing of files to the driver instead of the provider. But one of the things that, like Kubernetes supports is if the secret changes and the file a key is removed from the secret, right? It will delete that file from disk. But I'm not quite sure of how we would want to support that kind of flow, because right now the plugins return back, all of the files and then the provider just writes those. Is what's going to be released in the next release, and the driver writes those files. So it's going to be in the next release. But there's not any logic or way to signal to the driver that a file should be removed. So until like an unmount, nothing would delete a file. And so, yeah, I'm actually thinking about this. I'm not sure that the GCP plugin handles this case either of deleting files. I'm not sure if any of the plugins do, but it was just something that I deleted a lot of code when I was copying from the Atomic writer to ours, that noticed that there's a lot of logic around these sort of mutations. So yeah, I thought I would at least point that out and see if anyone had any thoughts.
Yeah, I mean, I don't think you were right? None of the plugins are actually delete today, because when we get a call from the driver to add these files, we basically loop through all of them and write those files. but we actually don't go and clean up anything that's there already on the file system. And I think the one possible approach is probably just, so right now the default behavior is what the providers already have, but I think maybe we can use the data returned from the provider as the source of truth. And every time we get the whole files object, we just write only those. So basically we write and then we delete all the extra ones and just make sure that there's only the latest. Because it's possible over time the user updates the secret provider class, right? So they have a SPC deployed, they have a pod deployed, and then they go and modify the SPC to remove some of the objects that they no longer need. Then I think at that point, they would just expect the driver to handle cleaning it up so that the pod no longer has access to those files via Kubernetes secret or from the files. Because for Kubernetes secret, we handle that case. Like we try to see if only the keys that are defined in the SPC, we create a data field using all those keys. And if there is a data difference between the one that we have and one that's already in the Kubernetes secret, we go and republish the data field. So we only publish the ones that is still relevant in the secret provider class.
Okay, so we handled this for syncing to Kubernetes secrets right now, but probably not on the file system.
Right.
And then I think there might be a little bit of weirdness between if the plugin knows that, like, oh, I'm not going to refetch the secret because of the input object versions, right? We need a way to differentiate between like no change versus file should be deleted. Okay, I guess I want to, before like fully switching or like suggesting people switch to the this new method, whether or not we think this is something that should be like a bug created and resolved.
Yeah, I think that that is a good option, starting off that way, because at least now we're not changing any default behavior, so we're not breaking anything. But I think that gives us the room to think a little bit more and see how we want to do that. Yeah.
Probably not put a V1 label right on the driver before, like, if it doesn't at least have kind of like that feature parity with normal Kubernetes secrets.
Yeah.
Okay. And then the next topic that I wanted to bring up is atomic file updates, where another big chunk of code that I deleted while I was doing this PR 481 was the Kubernetes secrets will write to a separate folder, and then after all the writes are done, it will do symlink the folder that is actually visible to the pod to the folder with the secrets in it. And since a symlink, I guess, is an atomic operation, this makes the view of all of the secrets change at once instead of, as each file is written. Or like, if I guess something is reading the file, like the driver isn't writing to it while it's another process has it open. This also, like, I don't think this is anything new that the PR added, like a new problem, but it was kind of like, hey, there's this difference between Kubernetes secrets behavior and what our drivers currently do, and whether or not we thought that was kind of worth creating a bug for and tracking. And yeah, I guess I'm also not quite sure on the motivation of the atomic updates, but yeah. wanted to bring that up and see if anyone else had thoughts on that.
Maybe to understand the motive, we can ask on the Slack chat. So maybe we can ping SIG storage to see what was the reason behind adding the atomic writer and what are the benefits of using it. And then if it's worth using it in our code so that it handles concurrent updates and it's more secure, then maybe we can switch to that. And I think another conversation that we had on that thread was if it's actually of value and if we can get it out of the core Kubernetes code and move it into the utils, then we can also work with SIG storage on that to move it out and then import that in our code.
Do you think that's SIG? Yeah, I guess that is. It's used by config maps and secrets right now. I'm not sure if anything else is using them. Okay.
So yeah, we can start a conversation in SIG storage first, and then if the point is elsewhere, we can follow that and go from there.
The Kubernetes issue you linked, it does talk about refresh, right? So is this how like Kubernetes refreshes the secret and config map and projected in the okay.
Yeah.
Okay. Maybe that's why.
Yeah, they write to a separate directory and then do the symlink after all the writes are done. For I think it's config maps and secrets. But I guess I'm curious, like it's interesting that we haven't run into a problem without doing this. So that's sort of like, I'm not sure how much of a problem it is, but yeah, it seems worth at least like addressing the difference between the behaviors there.
Right. Yeah. Makes sense.
Yeah. I'll at least create 2 bugs then for like deleting of files and atomic updates. And then we can talk with SIG storage Slack, right? Okay, thanks.
Okay.
I'm not sure who the note taker is today. Can someone update the previous stuff? I don't see any updates yet.
Yeah, I'll do it.
Okay, thanks.
Okay, and Rita, discuss comments raised in the disconnection scenario.
Yeah, I think there was a lot of people who commented on the doc. Let me find the link. That Anish started. Just thought maybe we could talk about it, I guess.
Yeah, I responded to the comments yesterday, but we can talk about it. Sure.
Yeah. Yeah, I updated the link. I think one, I guess, big item that I was kind of concerned about is the fact that if we make mounting as an optional thing, right, we could end up in a situation where the source of truth may be different for the Kubernetes secret versus the mounted file. Because so far we've been saying the mounted file is a source of truth, right? And the Kubernetes secret content is just a mirror of that, right? That has always been the stance. but with this potential change, how does that, we will basically now fall back to, okay, if mounting is an optional thing, then we assume the secret Kubernetes secret data is the source of truth, right? And then everybody will basically use that instead of the file mounted. So just want to see if other people have more thoughts on this.
Yeah, I think the reasoning that I added that was, there are two options, right? One is the pod could just mount the secret automatically directly instead of doing the CSI volume. So they do have the CSI volume, so that they force the CSI driver to create it, and then they have another volume which is basically mounting the Kubernetes secret, and then they can read from the Kubernetes secret all the time. And I think my concern there was the no-op volume mount, right? Like for the first part, yes, the CSI volume is being used because it needs to be mirrored as Kubernetes secret. But if they scale that deployment to more replicas, then the CSI mount is just a no-op call, and subsequently they're just using the secret. And the reasoning behind adding the Kubernetes secret as the source of truth is it's a fallback logic only in case of disconnected scenario. So only if the failure policy field is set, then the source of truth becomes the Kubernetes secret. But in all other cases, the mounted files would still remain the source Kubernetes, the source of the truth. But I think I understand what you're saying. It can get confusing for users because there's a difference in behavior just based on a toggle. And for that reason, I also added the other proposal that we were discussing. So I just added the proposal 2, which was using the dummy pod, right? So rather than using a dummy pod, I added that as a dummy deployment. So they use a dummy deployment with the CSI volume to create the Kubernetes secret when the cluster has network access. And after that, for all their application pods, they don't have a CSI volume. They just mount the Kubernetes secret as volume. That's it. So they have no dependency on the CSI driver after the dummy pod is deployed. So in that way, the Kubernetes secret will remain all the time, and then they can just have a single way of doing things, which is always reading from the secret volume. And I think one thing with that approach is also we don't need all these TTL fields. So we can still tie the dummy deployment to the, so we can tie the Kubernetes secret to the dummy deployment as an owner. And the reason for using a deployment is with the new release, we're going to be using the replica set as the owner reference. So that means even during the disconnected state, if a pod dies, it'll get recreated. But since we are using the replica set, the secret is still intact. So the user can control the lifetime of the secret by controlling the lifetime of their dummy deployment. So we are not changing any default behavior by supporting a new TTL, and we don't need to have a custom logic to go clean it up apart from what we do today. And I think one concern that had come up then when we had discussed was obviously having a deployment for each secret provider class, because it could be a one-to-one mapping. There is a potential to support one-to-n mapping. So one dummy deployment for n secret provider classes. So for within a namespace, if they have multiple secret provider classes, they can just use a single dummy deployment with all the secret provider classes with different volumes. So the CSI volume mount is no longer no-op call. It's actually something that's doing the mount and succeeding. And then it's creating the Kubernetes secret for the dummy deployment. And once network access is back, the CSI driver will go and rotate all the contents for the dummy deployment and also the Kubernetes secret. And because Kubernetes automatically updates secret volumes based on update to Kubernetes secret, they still continue to have the rotation feature in the cluster. So they're not losing any.
Do other folks have any opinions on this?
I had only read it like initially a while back. I I haven't thought about the disconnected scenarios in the last like few weeks, so I don't have anything to add.
And so in this, the dummy deployment is per secret that you want for a disconnected state, right? Is that my understanding?
Right. So typically the pattern that we see is for every secret provider class, it's a one-to-one mapping between this Kubernetes secret object and the secret provider class. So they want to mirror everything in the secret provider class as a Kubernetes secret so that it's available for them during the disconnect period. And we could recommend a 1:1 mapping between the dummy deployment and the secret provider class, but if they have lots of secret provider class, it can become too many dummy deployments. Instead, they can just have one dummy deployment with n volumes and reference all the secret provider classes within their namespace. So it's a 1:1 mapping between secret provider class and Kubernetes secret, and 1:n mapping between the dummy deployment and the secret provider classes.
Okay.
And the reason for using a deployment instead of static pod is just to make sure that they don't accidentally delete the Kubernetes secret by deleting their static pod during the disconnected period, because we don't want to change the logic for the owner reference, right? So we'll still add the replica set as the owner. So if they scale it up, scale it down to 0, it still won't affect us because the replica set is the owner. Only when the deployment is deleted will this Kubernetes secret also be deleted.
I mean, I like the second proposal approach because it requires less changes, I think, and it's more consistent to the current pattern, right? But what I add another con to this list is now the user has to run and maintain this dummy workload that has like resource footprint on the cluster, right? It's not super great if they have concerns about additional things that take up resource.
Yeah, I think that's a valid concern. But maybe we need some feedback on this from some users as well, because if we try to understand if they're okay with having one dummy deployment for the entire namespace, it can be a very small pod which is not really doing anything. In terms of maintenance, I think it's, yeah, I mean, yeah, they have to deploy this and maintain it over time. One thing I want to test out is scaling down to 0 replicas after the Kubernetes secret is created, right? If that actually works, then they don't really have to maintain it. All we need is that replica set object to just exist throughout the lifetime. So they can create the pod with the deployment, and after the Kubernetes secret is created, they scale down the deployment to 0. So the replica set still exists, and it's the owner for Kubernetes secret. So it would still stay. And when they are ready to get rid of the Kubernetes secret, they just go delete the deployment. So replica set goes away, and then we clean up the Kubernetes secret.
Yeah, I think that would solve at least that concern for me. Yeah, I can just hear users saying that. So
yeah,
yeah, that definitely let's curious what users will say about all this.
Yeah, I had the same concerns when I heard that, like just resource.
So I'm channeling Phil, basically.
Well, that's why I asked if it was a one-to-one mapping or how. You know.
And I guess like with this approach, like the net new thing is the TTL thing, right? Like other than that, like in theory, this works today, right? Like I could just deploy a dummy thing today, and there's no change on the driver side, right?
Yeah, and I think if users are selective about which secrets they want to maintain and then disconnected, then it wouldn't be all secrets in the cluster, right? They would just elect maybe a few that they care about, possibly? Or do you think this is all up kind of global type of config a customer would use this for?
So typically, whatever they have in the secret provider class, the assumption is they need that even during the disconnect period, right? So today, everything in the secret provider class parameters field, we add it to the mount, and then they can just provide a subset of that for the secret objects, has to be synced as Kubernetes secret. So they could have 4 files in the mount, but they only sync 2 of those as Kubernetes secret. But during disconnect period, if they think they would require all those fields, then they can just add all the 4 parameters to the secret objects and have sync all of them. But if they only still need a subset of it, and they're fine with the rest of them showing up after the network access is available again, then they can just have a few fields available there. But I think it makes it easier for the user to understand, because when they deploy their application pod, they don't have to have the CSI volume, which is going to be empty. They just have the single volume, which is just a mirror of the Kubernetes secret. And it's all native Kubernetes. And then so it handles rotation, and they always read from that single path. So they don't have any changes to their code.
Okay, so sounds like, maybe we can talk to a couple of customers who are, really looking to have this feature and kind of have them round it out for us, so to speak. Yeah. Okay. All right.
And for all the other folks on the call, like, please take a look at the different approaches, and please raise your hand if you think it's a bad idea or better way of doing this. Yeah.
Let's see. Shin just replied. So, did we answer this? How do you make sure that the files are no longer required? Is that? Did we answer that for you, Shin?
Yeah, I think we briefly touched on it. So looking at the mount response, right? So basically looking at the mount response to see the files that's returned. And as I'm writing the notes, like, one thing that I think we also should consider is we cannot use the mount files as the source of truth until we make that the default option, because until all the providers migrate to it, it's possible that the mount files returned is empty, and we don't want to accidentally go delete anything that's already there. So I think once we have all the providers migrate to it and say this is the default option, then we can add that logic to do the cleanup.
Good job.
Okay. I think that takes us to the end of the agenda for today's meeting. Is there anything anyone else wants to bring up to discuss or comment on? Okay, I think we're good. All right, thank you, everyone. Our next meeting is in 2 weeks. That'll be April 15th. So hopefully we'll see you then. And in the meantime, we'll try to get some customer feedback on this disconnection scenario. So again, if you have customers that may be interested, let us know. Okay, that's it. All right. Have a good rest of your day, everyone. And the meeting recording should be up in the next 48 hours. Thank you all.